She's had like a bad.
Okay, so we looked at solving by, you guys told me the 2 methods we've looked at so far. We're only going to look at 3. Substitution and graphing. We'll come back and review those. But we're going to learn a 3rd technique, probably the last one for this year. So eliminating variables is the idea. Elimination. So both of these, can you guys look at one and tell me, if you were given the choice, which one would be the one that would probably work out better substitution-wise?
The left one.
Easier, I should say. You said the left one.
Yeah.
Why the left one, Caden?
Actually, now that well, you could.
There's something in one of these that makes it pretty easy to substitute. So if given that choice, I'd probably pick substitution. I'm going to use elimination, but I think it's the left one. Because of the... Which x? This x?
The bottom x.
No, right here. This is already almost by
Itself.
so you could just subtract 4y and you'd get x equals stuff and you could plug that stuff in. Does that make sense? So that guy would probably work out substitution-wise pretty easily. It's super easy to eliminate that one though, so I'd still choose elimination if given my choice. So what do you do with elimination? Elimination is where you add the 2 lines or whatever. You can do this with objects that are parabolas too, or whatever. It's where you add the 2 equations together. So some people call this the addition method, and then they even do the subtraction method, but I don't like thinking about it like that. Let's just call this elimination. Because if I add these 2 together right now, what's going to happen? Something's going to go away. Think ahead. Miss Slade, you need to close your computer. The y's are going to totally go away. So I'm really targeting the y's here. They're going to be eliminated, if that makes sense. So the y's totally go away. So what do I have left? I have
4x equals negative.
4x, 0y goes away, equals 8. And that's the easiest equation in the world. So you just divide by 4 and you get 2. But remember, this is a system of equations where 2 lines cross. So 2 lines cross and half a coordinate. You just got to plug it in, just like we did before, no different. So you can pick which one you want to plug it in. I'm going to plug it in this one for the same reason we talked about its substitutability a second ago. Okay, you choose though, either one. So I'm going to stick it right there. Let's see, I'll get 2 plus 4y equals negative 2. Subtract. Divide.
1.
Positive 1.
Negative.
So we'd write the solution to this system is these 2 lines must cross at that spot. That'd be the x marks the spot for this one. All right. We could confirm that by graphing or anything else. But let's move on. So this guy I would definitely not choose substitution to do. Because there's no variable that's by itself. You could do it with substitution, but it's going to look pretty ugly. But if you do it with elimination, it's also got a little bit of an issue. Over here, what lined up?
It doesn't have
Y's lined up.
It doesn't line
The X's lined up.
It doesn't have to line up though.
And the answer is the numbers lined up. You don't have to make that happen, you're right, Richard, but you definitely want to get in this habit. It's a good habit, and then when you do matrices in Algebra 2 and other things, you'll have that habit already. So make sure it lines up if it doesn't line up first. So this guy, let's put it in the same order first. So let's make X come first in the top. Then I want Y to come next. So if I want Y to come next, I'm going to have to subtract it to the other side. So it's going to be minus 3Y now. And then equals, if I want this number to be on the other side of the equals, what do I have to do to move it? To go minus 15, minus 15. So you can show that, but can you imagine how messy your work is going to look if you show that? It's up to you. I think it makes it more complicated, not less. Up to you though. Okay. But this one, the X is already in the right spot. Nice. I want the Y to get moved over in its corresponding spot, so I'm going to add 3y to both sides, so plus 3y plus 3y. And then 5 needs to go over here. Minus 5, minus 5. There we go. Now it's lined up. So what do you guys think? What are we targeting, the x's or the y's this time?
Sorry.
If we target the y's, they'll just go away. I don't have to do anything special. This is not always going to work this easily, but we lucked out on this problem as well. So if I add these, the y's go away, and what do we have left?
Negative 5x equals 20.
These go away. Negative 20, divide by negative 5. You get 4. I'm of course not done because that's not a coordinate pair. So I can take that and plug it in. I can plug it in any one of these that I want to. I don't know, I'll just plug it into this one over here. So I'll plug it in up here. So 15 minus 3, x was 4, is 3y. 15 minus 12 is 3. Oh, nice. This one came out very nicely. So I got 4, 1. Okay? Don't expect your answers always come out so nice. You have to. So let's look at another problem before we do an application. Alright, so here's a third example where we're going to use elimination. In this example, I don't think the x's or the y's eliminate easily. What do I mean? Well, consider adding them together. So if you go 2x minus 3x, you get negative 1x. It's not gone. If you go 5y minus 4y, you're going to get y, not gone. That's two variables that are left, and you can't solve for either one easily in that case. So what we want to do, I think, in this case is decide. Do we want to try to eliminate the x's or the y's after modifying the problem? So we can use the Old Testament rule of algebra to multiply on both sides and rescale the problem into something that does eliminate. So my class chose to eliminate the y's. I don't think there's an easier choice on this problem. Some of yours might have an easier choice, so look carefully. So you want to think about what do both 5 and 4 go into easily. And I think the answer that my class chose at least is 20. You could try 20. They'd also both go into 40. Anything they go into easily will work. So if we want this to be 20, what can we do to both sides of the equation? Well, I think we could multiply by 4. All the way through. If we want this to be 20, we've got to multiply by 5. Now when I say 20, I mean negative 20, so that it'll be 20 minus 20, and the y's will go away. So what do we have left then? You want to definitely rewrite the problem at this point. Those students who I know in Algebra 1 are really tempted to try to do this without rewriting it, you're pretty much always going to mess up at this point. And even if you don't, you're developing bad habits. So it's up to you. So let's see, I'm going to distribute the 4. 26 times 4, you did pull out your calculator. I think that's 80 plus 24 is 104. Distributing the 5. 5 quarters is $1.25. And now you can see the y's will eliminate. So 8 minus 15 is negative 7. Gone. 104 minus 125. Use your calculator if you have to. I think it's going to be negative. My class said 21. And this probably does work out nice still. I think if we divide by negative 7, we'll get 3. So there's part of our answer. You can plug it in anywhere just as we've been doing. So you could stick it there, you could stick it there, there, or there. I'm just going to go on the top one and see what I get up there. So if I go 2 times 3 plus 5y equals 26, I'll get 6 plus 5y is 26. Subtract 6. And divide by 5, and you get your answers. So we're going to have 3 and 4 on this one. So if you're watching the video, hopefully you tried this one yourself first. Let's have a look at it. So I think this is a problem where the x's or the y's could be targeted equally easy. If you add the x's together right now, you're going to get how many? 4. But you could change this so easily by either multiplying the top or the bottom just by negative 1, then the x's would go away. That would work. You could also target the y's pretty easily. If this is 6y, you want this to be negative 6y to make them go away, so multiply it by 6. I'm going to do it this way, so I'm going to target my y's this time. So I'm going to multiply this equation by 6 and write it down again. So this is an instance, guys, where it is absolutely essential that you write it down again. If you try to do this without writing it down again, you're going to develop bad habits, number one, and you're probably going to mess it up, number two. So that's your choice. I would definitely invest the 3 seconds to write it down again. I didn't touch this equation this time, did I? So this illustrates also that you can either scale one equation by a number that's convenient to achieve your targeting, or you can scale both of them like we did a second ago. It's kind of up to you. You just want to get rid of something. You just want to eliminate something. All right, there's lots of different ways to do it. So let's see, then I get negative 6y equals 10, 2x. I'm good to go, right? I'm really not good to go. This should be 12x because this has to happen everywhere, or I disobey like the fundamental rule of algebra, which is do unto one side, so you do unto the other. You might go to algebraic hell if you do that. So I'm just saying, watch out, okay? This should be 60, or I'm disobeying that rule still. Okay, so now the y's are ready to go away. Add them together. What do you have left? 14x equals 80. Ah, this one's not going to come out super nice. If we go x is 80 over 14. We can reduce that a little bit. Doesn't 2 go into both?
Yeah.
So 47ths. That says 40. I think that's it. I think it's just 47ths. So that's about all we could do, right? So take 47ths and plug it in. I'm going to use this one because this one just got y by itself. So I'm going to say 2 times my 47ths minus y equals 10. So that's going to be 87ths. I want to get y by itself. So, you know what? I'm going to make this a whole lot easier. How can I get rid of that 7ths? God, I don't want to keep working with 7ths. This is a strategy that always works. I think I've mentioned it once or twice now. I could multiply both sides using the Old Testament rule by 7. Wouldn't that make this nice? Because then we won't have any fractions. I totally do that if you're working with fractions. So what, this distributed here is just 80, because they cancel. Distribute there. No more fractions, thank goodness. Your choice. Keep working in 7ths if you want. I'm going to subtract 80 to the other side now. What's 70 minus that 80?
Negative 10.
Negative 10. And divide your 7. And you get 10 sevenths. So the answer to my problem is going to be 47ths, 10 sevenths. I would really think about this step right here and how that can help you with algebra from now until the future, because if you really let that sink in, your life can get a lot easier with fractions. Okay, let's look at an application now. So what do you guys think the question is on this one? Lily's buying flowers, she buys tiger lilies. I thought that was a slight bit ironic. And she buys tulips. What do you think they want to know?
How many tiger lilies and tulips?
Yeah, like how many of each one, totally. So that's the question. How many of each kind did she buy? So we should have a system. And the way I do this in more advanced algebra is, for the system, I like to think about each line or each equation in the system being about some particular feature of the problem. What are the only 2 things we know about this problem? We know things about the flowers, how much they are exactly, their costs. So let's do a cost equation. See, when you get to more advanced algebra, this will really help you if you think about it like this. What else do we know about the flowers? Yeah, but I think we'll put that in the cost equation. Good, good. The other one's a little subtle. guys are gonna smack yourselves when I tell you.
Numbers off.
It goes back to, yeah, exactly, the amounts. What we're actually trying to figure out the correct combination of amounts, so we know like how many. And you used the word I was hoping for. Let's do it. The amounts. Okay? So we've got the costs and the amounts. All right. So, for the costs, what do we have?
Well, we have
$1.25 each. That each word was a clue to mean depending on how many. So should we call Tiger Lilies X? And then we're going to add up 90 cents for the tulips. We'll call tulips Y. And the total amount of money we're spending is $14.85. I think I left out a piece of information for the amounts. What else do we need to know? I did. I left out a piece of information. It's about 13 flowers. My bad. So how can I work that in? It's even simpler. The amount of lilies plus amount of tulips is 13. We totally needed that 13 or we didn't have a chance at solving this. Okay, so you could solve this by graphing, you could solve it by substitution, you could solve it by elimination. I don't care. So on this assignment, if you like substitution better and you want to do the applications with substitution, do it. This one's easy to substitute because of where? This one or this one is easy to solve for. I'd do this with substitution. If we had to do it with elimination, it's lined up, ready to go. You guys pick. Do you want to eliminate X or Y? I think either one will work on this one. Let's go for X this time. So if you want to eliminate X, what's this got to be?
125.
Negative 125. But how can you get that red thing to just go in there?
Multiply.
You got to go like this, right? So let's rewrite the system and do it that way. I'd do substitution on this one personally, but on your assignment, it's up to you. So we've got negative $1.25x. Now the x's will go away. Negative 125y. And negative 125 times 13. I'm just going to use my calculator on that. Let's see, 13 times $1.25. You could add it up. 1625 negative, exactly, because of the negative. All right, let's add it up. See what happens. Probably need your calculator. The x's are eliminated. The y's, let's see, 0.9 minus 125. On my calculator, I got this. 1485 minus that, definitely going to go to my calculator. I got negative $1.40. And then you can divide. Negative over negative is going to work out, right? Probably don't want negative flowers here, that would not make sense. This comes out nice and even at 4 what?
Flowers.
What kind?
Tulip or tulips?
If you go back, you can look at your key here if you didn't write it down like I've been suggesting, which I didn't this time. So that's 4 tulips. So think about this. Just use common sense now. If you've got 4 tulips and 13 flowers, then
We have
9 of the tiger lilies. Does that make sense? How could you actually get that? Take this, plug it in right there. That's the easiest way to get it. So we're going to say Lily she already did this, so she must have bought 4 tulips and 9 tiger lilies. Done. Okay, so there's elimination. You guys have about 10-15 to start working.